Hey, welcome back. My name's Todd McLeod. I'm your teacher here in Computer Concepts. We're in Module 10 and we're looking at Chapter 10, which is going to cover programming. Last week we were looking at Chapter 9. In Chapter 9 we looked at securing your system, protecting your digital data and devices. But this week we're going to take a look at programming. And the best way to learn about programming is just to see some programming and also to use ChatGPT. And so at ChatGPT, we could put in a prompt here. And so I'm going to pause the video while I formulate this prompt just to keep your video shorter. Hold on. Okay, so I'm recording again, and I put in this prompt here. I'm a professor doing an example for my college class here. What are the world's top 10 programming languages? So I'm going to just hit enter on that. And when I do that, I just have to click right there. Let's go. And it's going to list out the top 10 programming languages in the world. And you can see here that it's giving me two options to look at. And so when ChatGPT does this, it's actually how it's training its own self. And it's giving you different responses. And then you look at that, and then based upon the response that you choose, it's learning which response people like better. And this is using the paid version of ChatGPT. So there's a free version and there's also a paid version. The paid version is always going to be better. It's the most recent model. It's more powerful. It's going to do more stuff. And so here you could see the top 10 programming languages in the world. And you could also see what they're used for. So Python, right? It's widely used for data science, web development, automation, artificial intelligence. So that would make Python a great language to learn. JavaScript is essential for web development, front-end frameworks, and increasingly popular for back-end development with Node.js. And so both of these allow you to do web development. JavaScript is more geared towards web development. Python has more flexibility, right? But if you're going to learn to create software, if you're going to learn to program software, so whenever, again, you think about the ontology of computers, we have computers, and then computers are broken down into two parts, right? And those two parts are hardware and software. And so software runs on top of hardware. And when you think about the stack of like how do computers work, you have the hardware and then you have software on top of that hardware. And the first piece of software that you have is the operating system. And then on top of the operating system, you have application software. And so all that software has to be written. And when you write this software, you write it with a programming language. And so there are different programming languages out there, and different languages serve different purposes. And they're built for different reasons to solve different needs. And so Python and JavaScript are the world's two top programming languages. And they're the top programming languages because one, they both do web development, and web is huge. And then two, Python also does artificial intelligence, and it also does data science, and it also does some automation stuff. And so Python's a very versatile language. It's really easy to work in, and so yeah, it's like an easy language to write. And just like when you learn any language, whether it's French or Italian or Spanish or Python or JavaScript, it takes you a while to learn how to speak that language. You have to learn the different ways people speak that language. You have to learn the different idioms or the different patterns of speech. Like in English, I would say, hey, do you want to go get a burrito? But in Spanish or in Italian or in French, there'd be different patterns of speech, different idioms that are used to express that. Likewise, with the different programming languages, it's almost like learning a spoken language. There's different idioms or different patterns of speech with each of those languages. And while there are similarities between languages, whether it's French, Italian, German, Spanish, or English, there's certain things that all of those languages have in common, or even Russian or Chinese. We're making sounds, we're using our mouths, right? There's nonverbal communication that goes along with the verbal communication. There's certain things which all languages have in common for spoken languages, and that's also true for programming languages. So in any of these languages, whichever language you chose, Python, JavaScript, right? And I'll say a little bit more about these languages here in a moment. Like there's going to be things that are common between all those languages. For instance, they're all going to provide some way to do conditional logic, right? So when we talk about conditional logic in programming, we're talking about flow control. And conditional logic is like basically like it's noon. I haven't eaten since 8 a.m. Do I want to get lunch? Right? And this is a conditional logic moment. Okay, it's a place where I'm either going to choose yes or no. Conditional logic, and based upon one condition, I'm going to do one thing, and based upon the other condition, I'm going to do another thing. Conditional logic. If I say yes, I'm going to lunch, then that's going to lead me out my office door. If I say no, I'm going to sit here and keep working, then that's going to allow me to get more work done. So when you write programs, right, one of the things you use is conditional logic, and that's often with if statements. And both Python and JavaScript are going to have ways, and all these programming languages here are going to have ways to do conditional logic, where you're like, hey, based upon this, do this or do that. And so when you're writing a program language, that's one of the idioms that's common to all of the languages, is having conditional logic. And so there's actually 3 types of flow control. And the first flow control, or one of the types of flow control, is sequential. Another one's conditional, as in conditional logic. And another one is iterative, as in loops. And so to illustrate the iterative, and this is something that would be common to all of these languages, the iterative would be like, you know what, I need to calculate the grade for a student. So I'm going to write the formula to do that, add up all their scores, divide by the total number of things that they did. That will give me the average, right? And that's how I'm going to calculate the grade and for each student. And so once I've written that, I now need to do that for each student. So what I'm going to do is I'm going to do some sort of a loop, and there's loops like for loops, where I want to loop over stuff over and over and over again, and that's called iterative or iteration. So when we're talking about flow control, we have conditional logic, we have iterations, right? So conditional logic, if this, do that, or otherwise do this other thing. That's conditional logic. Iterations are like loop over this stuff over and over and over. For each student, do this grade calculation, and they'll do that for every student in the class. So when it's all done, and say, okay, I calculated the grades for all the students. So the flow control here, we have sequential, we have conditional, and we have iterative, right? And so conditional is that conditional logic. The iterative is the loop, keep looping over it. And then sequential, in sequential, when you're writing code, your computer is going to read the code from start to finish, just like we read a book, right? It'll start at the beginning, it'll go to the end. It's going to read it in sequence. And then while it's going through that sequence, it'll hit conditional, and it'll make decisions to go one way or the other. And it will also potentially hit iterations or loops, and it'll do something over and over and over again. And that's known as flow control. Flow control, you're controlling the flow of how the computer's reading the code in the software. And so you're learning some things here. The first thing you learned is that here are the top 10 languages in programming. So if you're going to learn to program, these are the ones that are most desired. The second thing you're learning is that when you have hardware, you need to write software to take advantage of that hardware, right? And you could write the operating system, or you could write application software that runs on top of an operating system. The third thing you're learning is that when you write software, you're going to use, when you program, you're going to use one of these programming languages. Okay, and so here they are. And each of these languages has a different purpose, right? They have different purposes. They're built for different reasons. And so you could read a general overview of each of the purposes of these languages here. The next thing you're learning is that when you write that software, there's 3 types of flow control. There's sequential, top to bottom. There's conditional, like make a decision, go one way or the other, right? Go to lunch, don't go to lunch. And then there's iterative or loops, right? So it's the 3 types of flow control. As we're learning about programming and as we're learning about different programming languages, I want to point something out to you. And so there's something called the Stack Overflow Developer Survey. And hey, 2024 results. Let's see if they have that one. It's right here. And this is a really great thing to peruse if you're into programming or wanting to get into programming, because the Stack Developer, what's it called? Developer Survey, the Stack Overflow Developer Survey shows you like all this information about programming and the programming field. And so learning to code, online resources are the top choice for developers to learn to code, according to 82% of responses. Respondents 18 to 24-year-olds are most likely to learn to code at traditional schools of all the age groups, and consistently so for the last 3 years. And you can look at other tools and programming, scripting, and markup languages, admired and desired, right? Web frameworks, technologies, AI developer, search AI, top paying technologies. That's kind of interesting. All AI tools, are AI tools a threat to your job, right? There's a lot of interesting stuff here. So we might take a look at top paying technologies here, and then we might also take a look at admired and desired languages. And there's more stuff here that you can look at, like developer profile, technology. If I click on that, most popular technologies. And so here are the most popular programming languages. So JavaScript, 62%. And notice that this is like slightly different here compared to what ChatGPT put out. So the most popular technology is JavaScript here, but over here it's at, and that's okay. These could differ because Python is probably like, if you're going to learn a language, this is a great first language because it's a little bit more general, right? Data science, automation, AI, like that's a great language to get into, and web, because you could do a lot of stuff in Python. And it's also a better language. It's a better language. It's just built in a more traditional computer science kind of way, whereas JavaScript is a little bit cobbled together in my perspective, and they've had to like fix it and fix it and fix it for the last 25 years. So it just wasn't built that great, and they just have all these changes and updates. So I would go with Python if you're going to learn a language, but JavaScript is really useful and really popular, and you can see that here. And then HTML and CSS, this is used to create actual web pages. So when you build web pages, there's the web page with these words, right, and this layout. So the HTML is the hypertext markup language. That's where if you right-click this page and you choose View Page Source, you're going to see all this code. And all of these things, if I scroll down here, I'm just scrolling. So all of these things here, HTML, you see body, div, script, all that stuff down here. And here's a script. So here's some JavaScript that's running on this page. And up at the top of this page, if I scroll back up, you're going to see some more HTML tags. And so here, document type is HTML. But then right here, you've got CSS, okay? And then there'll be other places where it's pulling in CSS too. And so the CSS, the HTML structures the web document, and then the CSS formats it. And so HTML and CSS are for building the actual pages. And then JavaScript or Python or Go, those are going to be used for, like, when I send a request to the server and the server sends the page back to me, this page right here, like Python and JavaScript and Go can be used for server-side programming, so the server can respond with the web page. And as I submit a form, it can validate the web page. And then JavaScript can also run, so that's called server-side programming. And JavaScript and Python and Go are all good for that. And then client-side programming is like, code is actually running on the client's computer. And it's like doing some of the processing for the web page right here on the client's computer. And JavaScript's the language that does that. So JavaScript does both client-side and server-side. Python just does server-side. Go just does server-side. So if you build web pages, you're going to have to use JavaScript and HTML and CSS. HTML builds the structure of the web page. CSS formats it. JavaScript does client-side processing. So, processing on the client side, and then server-side processing when I request something new from the server, like if I was to go to, I don't know, what is North Shore, Hawaii. When I put in that request went to Google. Google processed this request and then sent me back this page here. And so the server doing that processing and sending things back to me, that's server-side programming, okay? And so JavaScript, Python, and Go do server-side programming. So there's different languages for different tasks. And you've learned about JavaScript, you've learned about Python, right? And now you've also learned about HTML and CSS, which doesn't show up here as a programming language because it's more of a markup language. It doesn't do the flow control of sequence, conditional logic, and iterations, okay? But it's needed in website development, and it does the structuring of the document and the formatting of the document. So that's like a little bit of the different languages, and I wanted to show you the Stack Overflow Developer Survey because this is a really useful thing to look at when you're thinking about, should I get into a language, or what language should I use to build some software? So part of the decision for which language you choose to build software is like, is it a language built for a certain task? Like if I wanted to do artificial intelligence programming, Python, right? Or data science, Python. If I want to do website server programming, Python or Go. I'm not going to touch JavaScript on the server side. You know, it could also be good because one language you could do client side and server side. But I'd rather learn, like my two choices for languages that I would learn would be Python, Go, and SQL. And then after that, I would pick up JavaScript. And I do that kind of way right there. And if you only had to do one, I do Python, and then I learn SQL, which is for databases, talking to databases, and then I learn JavaScript. Some people will say, hey, just learn JavaScript because once you learn it, you'll be able to do client side and server side. But I think that it's kind of a crappy language, and you'll get a better sort of foundation if you use Python. And then I'll tell you about my favorite language out of all the languages, and it's a little bit more high end. And that's Go. And the reason I like Go is it's got a really interesting story. And so here is like Go language, right? Here's the website for the Go programming language, go.dev. And it was started by Google. And so in 2005, the first dual core processors were released. 2005, the first dual core processors were widely available on a commercial basis. And so before that, every computer had only a single CPU in it. And then 2005, 2006, dual core CPUs came out. And at that same time, Google started, three guys at Google, Rob Pike, Ken Thompson, and Robert Gressmer, started building a language to take advantage of multiple cores. And so prior to that, there was no language that easily and natively took advantage of multiple cores. And so what's that mean? So when you have a single CPU and you run software, all of the instructions have to go through that single CPU, and they go through in a sequential fashion, one after another. Okay, now that you have two cores, you have more possibilities. Can we take the instructions of our program and run those instructions through both cores at the same time? And prior to 2005, 2006, there were no languages that easily or natively did concurrent code that allowed you to do parallel processing. So previously with sequential processing, in sequence, the instructions would go through in sequence one after another. With multiple cores, can we have the instructions go through both cores in parallel? So basically we're processing twice as fast. And to go from sequential processing to parallel processing, to do that, you need a programming language that allows concurrent programming design patterns, okay? And so these gentlemen at Google started to create a language called Go in 2005, 2006 to natively and easily take advantage of multiple cores so that this language could write concurrent programming design patterns. And then when you ran this language on a computer that had multiple cores, the software that you'd written using concurrent design patterns in the software could run in parallel across multiple cores. So I'm using some words there. And the words that you should identify are sequential, right? So instructions going through a CPU in sequence, one after another. And then also parallel. So instructions going through multiple CPUs in parallel at the same time. So your choices when you're running instructions through a CPU is that they could either go in sequence or they could go in parallel. And the difference is like a single lane road where each car is going one after the other, okay? And if one car is going slow, all the cars have to wait. Versus in parallel is like a multiple lane freeway where you have all of these cars running in parallel at the same time. Though using that analogy, in the analogy, the cars are different pieces of instructions that are in your software that could run in parallel at the same time down this multiple lane freeway, this multiple core computer. These instructions can run through these cores in parallel at the same time. So concurrent, parallel. Now, to do parallel processing, you have to have a programming language that you could write concurrent program design pattern, right? So you could write design patterns in your software that are concurrent. And if you have software that has concurrent design patterns and you run that software on a computer with multiple cores, that software with concurrent design patterns can now run in parallel. So sequence, parallel, and then the program, when you write the program, if you write concurrent design patterns, that program can run in parallel, okay? Because a lot of people get confused about concurrent versus parallel. And so Google built this language, Rob Pike, Ken Thompson, Robert Gressmer, and these guys are like the Babe Ruths of computer science. And they created the C programming, helped create the C programming language, the Unix operating system, and then also UTF-8, which is the world's leading coding scheme. And so they basically built the bedrock foundation of computer science, and then they built a new language at Google, one of the best, if not the best software engineering firm to have ever existed. They built a new language there, and that language is Go. And now Google uses Go to do what Google does. And so some undisclosed amount of Google, the search engine, is written in Go, and all of YouTube is written in Go. And so Go does what Google does, and it's built for running software really quickly at scale, right? In distributed systems. And so it's an amazing language. It's very exacting. It's very precise. It's very engineering. There's no ambiguity. You have ultimate control of writing that language right down to the hardware, completely taking advantage of the hardware, eking out every last iota of performance out of that hardware. You could write code which has incredible mechanical sympathy. So the code really knows how to take advantage of the machine, right? You could write code with incredible mechanical sympathy and really take advantage of it. So it's a great language to know. It's an up-and-coming language. It's still growing. It's still new. It's got a great community. And so if you were to learn programming, I would really recommend starting with Python. And after you've done Python, like maybe take a SQL class. And after you've done SQL, jump in and learn Go. And that will give you a super solid foundation, like if you go the computer science route. And then after that, you can pick up some JavaScript and HTML and CSS, just because annoyingly, it's all over the place. And you might want to put together some web pages sometimes. So it's a little bit about different programming languages and the Stack Overflow Developer Survey and the Go programming language. And we'll also look at these pages here for top paying technologies. And so you can see different languages pay higher amounts. These are usually more, these up here are like less developers, and so they have to pay more to find them. And Go is right here. Go pays pretty great. And I'm just looking to see where is Python in this list. So I got to do a Control F or Command F, and Python, MicroPython's right there. Like Python isn't even registering for some reason. I have no idea why Python would not be on this top paying technologies. So I'm just gonna see where Python. So here Python pays at 78,000, and now it's 67,000 in 2024, and then I'm just looking through here to see other places. I don't know what MicroPython is. So maybe MicroPython is, Python that runs on micro devices. I don't know. So I'm just going to go back to the top of this page. Anyhow, you could take a look at, basically once you learn to program, you could work in a variety of different languages. And then admired and desired languages. So Python's at the top of the list of admired or desired. And then SQL's after that. And, desired maybe just because, we want to do client-side scripting. I wouldn't put JavaScript anywhere near admired. And then Go is also, admired and desired right there. So there's some good courses if you want to learn Go. There's some good courses online that you could check out. I've created a series of courses on the Go programming language, which you could find by going to Udemy, Todd McLeod, and you can check out my intro to Go programming. And that course is gives you a really strong foundation in computer science and all the different aspects, the functions and everything right here. So there, you could check that out right there. All right, so that's a little bit of an introduction to programming, and I'm just going to pause the video and see if there's anything else I want to say about that. Hang on one second. So I'll freeform just talk about a couple of aspects of programming. So one aspect is that when you program, you create algorithms. And so that's a word which could sound a little bit, and I want my ChatGPT, I don't know where that went, there we go. An algorithm is like, please define what an algorithm is. There we go. And so an algorithm is just a set of instructions to handle some task. That's it. That's all an algorithm is. And so we use algorithms all the time in our lives. There's an algorithm that you use for your morning, on a school morning or a work morning, right? Get up, shower, dress, eat, get out the door, right? There's a series of steps that you go through to complete a task. And that's all an algorithm is. So it's a fancy word for something all of us already do. And when you create a program, you're building algorithms, which are different steps that you take to complete a task. So that's what an algorithm is. The next thing, which is interesting to know, is in programming, is that there's testing and there's also debugging. Please talk about testing and debugging a program for beginners. Providing an explanation that's appropriate. Providing an explanation that is appropriate for beginners. There we go. So testing, when you test software, you're going to write software to test your software. And so you'll say, here's my algorithm, and this algorithm is going to calculate students' grades. Now I'm going to write a couple of tests. And what if the student had, an 8, a 10, and a 6 on 3 things? What average is calculated? Well, the average of 10, 8, and 6 is 10 plus 8 is 18 plus 6 is 24. Divided by 3 is 8. So if I run that testing software against my software and I get something other than 8, I've got an error in my program. So you write tests to test your software to make sure it's right. And debugging it is when you debug your software, you're looking for bugs in the program. You're looking for errors in the program. So testing and debugging are, testing is, trying to find bugs. And debugging is trying to get those bugs out of your computer, debug them. And that phrase debugging actually comes from the first bug in a computer, and it comes from journal. It comes from somebody's journal. I'm spacing out her name. She was an admiral in the Navy. And here it is. And in the old computers, they were big and they had vacuum tubes and they were hot. And they would go in and they would pull the moths out, the bugs out that caused things to happen. And so this was the first actual case of a bug being found in the computer, and they taped it into the journal. And the person who did that, who is the person? We'll ask ChatGPT. Who was the person who found the first bug in a computer? Was what I think Grace Hopper. Was it Grace Hopper? So Grace Hopper was this woman who was a computer scientist and mathematician, and she was in the Navy, I believe. Yep, in the Navy, and she was an admiral, and so she did a lot with computers, and then. She also had really cool quotes, if you look up her quotes, one of them is that a ship at harbor is safe, but that's not what ships are for. And another one is that it's easier to ask for forgiveness than permission. Yeah, so she's got some cool quotes too. So yeah, Grace Hopper is the one who found the first bug in a computer. So that's testing and debugging. And then let me think about this here and see what else there is to say about this. Hold on one second. All right, and so the next thing I want to share is that what does Jensen Huang say about programming? Does he say that computers and AI will do most of the programming in the future, and that there will not be as much need for programmers? So AI is really pretty good at programming, and Jensen Huang is the CEO of NVIDIA, which is one of the world's most valuable companies, and has spoken extensively about the future of programming in the context of AI advancements. He envisions a shift where AI and computers take on a larger role in automating many programming tasks. But he does not suggest that this will eliminate the need for programmers altogether. Instead, Huang sees AI as a tool that will handle much of the repetitive lower-level coding, allowing programmers to focus on higher-level creative and strategic aspects of software development. I totally agree with that. And you can pause the video and read the rest of this. Can you please, and so here's the next thing to know about learning about programming, is you could go to ChatGPT and you could say, can you please tell me how to write, or can you please show me how to write a basic hello world program in the Go programming language and explain the different parts. And I'm just going to say please, because I made that a question, but I didn't feel like putting a question mark. I just kind of like say, please show me. All right, so now this is how you can start to learn to program. So you just go to ChatGPT, and you have to have enough information to ask the question. So that's where you might, take a class. But here I've asked, in programming, there's always a hello world program. And the hello world program is like the first program you learn to write in any language. And so here it is in the Go programming language. And then here it explains the different parts of this program. And so you could pause the video and you could right here and you could read about all that. And then you could also pause the video right here and you could read the rest of it. And so I'm going to copy this code, and then I'm going to go back to the Go programming language website. And when I'm here, I could go to, there's a place where you could try Go. And so I'm going to just click on, seems like there's another place where, let me find it. Hold on one second. All right, so I'm going to show you how to find it. So I got here by putting Go programming language. I'm going to type in playground after that. And so here's the Go playground. So it's just /play. And now I could copy all this code and just delete this. And I could paste in that code I got from here at ChatGPT. And then I could run this, okay? And so now it's printed out hello world down there. And I could change this if I wanted. I could say class. And maybe I want to say computer concepts class. There we go. And now I could run this. So now it says hello computer concepts class. And then I could ask, ChatGPT, can you please, and sequentially you could see here this code's running in sequence from top to bottom. And I'm going to say here, can you please give me an example of conditional logic using an if statement in the Go programming language? And again, I'm just going to change this to please. Please. Boo. There we go. And so here's this code, and hopefully it'll explain it. So it's explaining it again for me. And so I could copy this code, and I just copied it, and I come back over here, and now I could select all that code, Control A, Command A, delete it, and then Control C, V, or Command V, paste in the new code. So here I'm declaring a variable, and this is the short declaration operator, and I'm saying take the value 20 and assign it to the variable age. And so we use variables to store values. And those values, we could then check them. So if the age is greater than 18, print this, and otherwise print that. So when I run this with an age of 20, it's going to say you're an adult. But if the age was 17 and I run this, it's going to say you are a minor. So that's conditional logic. Okay, so again, we're using sequence in control flow, sequence, and then we got here, and this became conditional logic. And I could say here, and a loop statement with for. And so now it's going to do a loop statement here for me. And so I could copy this code right there, and I could bring it over here, and I could paste it. And now here what this code does is it's like for I, we're declaring a variable, and we're setting that variable equal to 1. So that's your initializer. And then here's your condition. While I is less than or equal to 1, we're going to do this. And every time we get done doing that, we're going to add 1 to I. So it's going to start here, this loop, and it's going to be I is equal to 1. It's going to print that. Then it's going to go back up here, and it's going to say is I, which is 1, less than or equal to 5. That's true. So it's going to add, it's going to come back up here. It's going to add 1 to I. So I will now be 2. And is 2 less than or equal to 5? That's true. So it'll print that. And then I'll come back here and add another 1 to I. So I used to be 2. Now it will be 3. We'll say it's 3 less than or equal to 5. It'll be true. So it'll print 3. So when we run this, we get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 printed out. And we could change this. We could say, hey, less than 10. Right? And we could run it. And then it's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we could see, like, how high will this go? Will it do 1,000? Like, at what point does this server, this remote server, start to say, you know what, I don't want to do all that work? So it did 1,000. Will it do 10,000? Right? We run that. And now you start to see the power of computers. And so at some point, the server is going to say, look, I'm not going to process this request because I'm a server. And I'm going to limit how much people can do on the server so my server doesn't get overwhelmed. But if you were running this locally on your computer, you could run like, big. You could go big, 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 and you don't have any limit. So we went up to 10,000. Now we're going to try 100,000. Like how long would it take for a computer to print out 100,000? We'll see if it doesn't like us, if we went too big on it. And that was how long it took for the computer to print out 100,000, every single digit. From 1 to 100,000. What about a million? How long would it take to print out a million, right? Let's run it. Let's see if the computer balks. So it's waiting for the remote server. And at a million, it said it's taking too long, right? So we could try 200,000 or whatever. But locally, it would do it. And that is how you do loops. And so you could start to learn programming. It's learning a new language. There's syntax to the language, and in that course, I teach you all about that. So if you wanted to learn more about the Go programming language, you could take that course and figure it out. And if you need an access code or a coupon for that course, feel free to message me. All right. What else can I share with you? I guess at this point, we could browse through the textbooks presentation, and we'll just start here and we'll look through this. So some tasks are complex and they require humans, right? And computers can't do them as well. Though now with AI, computers are like way more powerful and they could do a lot of stuff that computers used to not do. And this is the interesting thing about AI. Switching topics here. Do humans explain what the black box is. Black box is in relation to AI and how humans don't truly understand how AI does what it does. All right, and so this is a really interesting thing because we've created technology which we don't understand. And so the black box in AI refers to the phenomenon where the internal workings of an AI system, especially complex ones like deep neural networks like ChatGPT, are not fully understandable or transparent to humans, even to the people who design them. So we've created software that works, and we don't know how it works, right? Like, yeah, we understand the intricacies of how we built it. And then we told it to go out and learn stuff, and it learned stuff, and it came back, and we're like, holy cow, how did it do that? Right? We taught it to learn, and it did it. It went out and learned, and it came back, and it can talk to us. And so that's super fascinating. So computers are actually, able to do a lot of stuff which previously they couldn't do now that AI is here. Traditional programming, right? It allows us to automate repetitive tasks. And so traditional programming makes things, possible for automation. So some tasks like calculating the grade in every class or analyzing different stocks. Really traditional programming is about conditional logic and loops, and we're creating the algorithms to process stuff, and we know each step of the processing. With AI, we created a program that knows how to learn. It went and learned, and we don't know how it figured out the stuff it figured out. It used statistics and stuff like that. We know that, but we're still mystified, like, whoa, look at what it knows, right? And we don't know how that happened. It's the black box of AI. And so, and by the way, as you learn more, what you truly learn is how little we have learned, okay, as humans. And so just to illustrate, as you learn more, what you truly learn is how little we've known as learn. As you learn more, what you truly learn is how little humans have learned. As you learn more, what you truly learn is how little humans have learned. And just to illustrate how little humans have learned, can you please, is it correct that 95% of the universe is dark matter and dark energy, and we call it dark because we know it's there, we can measure it's there, but we don't know anything else about it? Yes, that's largely correct. Scientists estimate that 95% of the universe consists of dark matter and dark energy, right? And we know that that is there. Like our math, our science says there's like a whole lot more mass and energy that's there, but we can't observe it. We don't know anything about it. So maybe it's a multiverse, or who knows, right? We don't know. And so everything that we can observe is only 5% of the mass and energy in the universe. So you could pause the video and you could read this. So as you learn more, what you truly learn is how little humans have learned. As you learn more, what you truly learn is how little humans have learned. Kind of fascinating. So some repetitive tasks are candidates for automation, and you could write software to do that with traditional programming. Programming careers, generally in the past, plentiful jobs, strong salaries, and they allow telecommuting. But if you go and you search the news, Google News, and it's always going to be a fine field if it draws you. But if you search the news for tech layoffs, right? Like the last 2 years, there have been a huge number of tech layoffs. Tough time to be a tech graduate. AI and layoffs have made it a competitive job market, and salaries are really down for programmers. ByteDance lays off hundreds of TikTok employees in the shift to AI content moderation. Massive layoffs at Cisco and IBM erase hundreds of Bay Area tech jobs. Amazon layoffs cut 14,000 manager positions by 2025. Mass layoffs hit tech industry, over 27,000 jobs cut as Intel, Cisco, IBM, and Apple slash workforce. I'm quitting big tech after a decade in the industry and 2 layoffs. Comprehensive list of 2024 tech layoffs. A millennial's been looking for a tech job for over a year after being laid off. He says AI and being black have worked against him. So that just goes on and on. And I actually have a family member who is a CEO of a very high-level, prominent organization, and he got laid off. The CEO. So the company that he worked for, if I told you the name, you'd be like, I know that company. They have like sub-companies, and he ran one of the sub-companies, and they closed the entire sub-company down. Programming is needed when no software exists for a task, and macros execute a complicated sequence of steps with a single command. So when you use Microsoft Excel or Microsoft Word, you could create little macros, which are kind of like little programs. You could actually do a little coding in them. and those little programs are called macros in Word and Excel. Then, an information system is like the entire system for taking data and turning it into information. So all the people, all the procedures, all the hardware, all the software, all the data, that's an information system. And and that includes the software, the programming, right? And when you create an information system, it's called the systems development lifecycle. And it's just a problem solving process. You identify the problem or the opportunity, you analyze it, you design a solution, you develop it, you create the software, you test it and install it, you install it and test it. I'd switch those. And you maintain and evaluate it. And then when it sucks, when it's no longer working, you rebuild it. And so right here where you develop the software, that's the programming development lifecycle, which is another problem-solving process. You describe the problem, you make a plan, you code it, you debug it, you test it, and document it. So that's software development lifecycle and the program development lifecycle. You can see that here, program development lifecycle, system development lifecycle. I think of it as software, but system's the right phrase. Problem statement. So when you create a program, you got to say, hey, what problem am I solving? And then you want to interact with the users and see what do they really need. And there's a lot of books around that, like, how do you build software for people that, that's going to be stuff that they really need. And so again, at ChatGPT, can you please provide me with the top 10 most popular books for product managers and include in the list 0 to 1 by Teal. So 0 to 1 by Peter Thiel, and Inspired by Marty Kagan, and Hooked, How to Build Habit-Forming Products, and Lean Product Playbook, and Measure What Matters, and Crossing the Chasm, Design for Everyday Things, and Cracking the Innovator's Dilemma. All those are great books. And so that would help you figure out, like, how do I build software for users that they're actually going to need. And then we have error handling and testing. We talked about that. You could read there. And we have algorithms, and we talked about that. And it's just a series of steps that you use to solve a problem. Then we have pseudocode, so you can kind of write out what an algorithm is going to do. You can say it's going to do this, it's going to do that before you write the actual code, and that totally is called pseudocode. All right, and then you could write flow charts, and so flow chart uses these symbols to kind of create, like, this is how things are going to happen in the program. We're going to get input, we're going to have some conditional logic. It'll go this way or it'll go that way. So that's a flow chart. You could break things down using top-down design. Like, here's the first part broken down. We break each of these parts down like this. And after we broke this down to this, we break it down to this and write a little pseudocode, right? Before we actually program it in the programming language. And then choosing a program, you want to be able to have your software run on different systems. So the Go programming language can compile and run on a Mac. It can run on Linux. It can run on Windows. You can write the software once. You can compile it into an executable that will run on many different hardware platforms. And so that phrase there, that word there, compile. So you write the software in your programming language, and then when you're ready to turn it into an executable, program that will be able to run on hardware, taking it from the programming language down to the executable, you're going from the language down to zeros and ones that will run on a specific machine, and that's called compiling. You're compiling, turning it into, I think of it compiling as turning it into a pile of zeros and ones, a pile of bits, and they're going to be zeros and ones specific to a certain hardware. Windows, Mac, Linux, right? So you go from the programming language down to this pile of zeros and ones, and that pile of zeros and ones is, you've compiled it down to that pile of zeros and ones to run on specific hardware. We learned about variables. We saw that variable age. Variables store values of a certain type. A good programming language will be statically typed, not dynamically typed. which means that when you declare a variable, it's going to store a value of a certain type. The age variable in that one program we created, it's not here anymore, that age variable stored a value of type int, an integer. And by declaring that a variable is going to store a value of a certain type, you avoid a lot of errors. And so you like static typed compiled languages. Those are better languages. JavaScript's dynamic, though, because JavaScript tries whatever. It also has a flag you could switch to make it static, which is recommended. Compilation, we just learned about that. The compiler is the software that does the compiling, takes it from the programming language down to a pile of zeros and ones, a pile of bits. An interpreter does it line by line. Instead of turning it into an entire executable, it just like interprets the lines as zeros and ones as needed. It's not as good. Debugging, testing, we learned about those. Logical errors, 2 plus 2 equals 5. That's a logical error. Because 2 plus 2 doesn't equal 5, it equals 4. That's a logical error. You could create programs with logical errors that run fine, but they give you the wrong result. A runtime error is like if I declared a variable to store a value of type int, and I tried to store some other value in there that was like a string, like text, that would throw a runtime error. It'll say, I can't compile, you have an error. So that's a good check, because you'd be like, oh, I made a mistake there, let me fix it. A debugger helps you find bugs in your software. And you don't need to know anything about that. Here are the different languages that are out there. And, we already talked about them. And things you need to consider when choosing a language is, what are you trying to do? What language is good for doing that? How many developers are available in that language? Because you could have a great language for doing something, but if you can't find a developer, then what's the point? So Python and Go and JavaScript and SQL and HTML and CSS, that's your bread and butter right there. And so C and C++ are old school languages. They'll be used if you're trying to program hardware at a low level. You could use C and C++. They're really fast, but Go's really fast too. So see if Go will do it. And Go is a part of the C family language. Java sucks. Just stay away from Java. And sorry I've used sucks twice. That's not professional. I'll move away from it. And Swift is like for iOS programming. And then this is just completely wrong right here. So XML and JSON, and I can't remember, but I'm pretty sure Ajax. Those are all for serialization, which means you're taking data and moving it from one place to another. And so this isn't about creating web applications that update and communicate with other computers, because you're not creating a web application. This is about communicating information between computers. That's how you'd say that. Communicate, let's just put communicate information, data, communicate data. My finger's in the wrong spot. Data with other computers. There you go. Serialization. And last slide. We always need a variety of languages. Okay. I'm not sure what this is. Like future of programming languages. Not easy to predict. Need for professional programmers. Will there be a need for professional programmers with AI? Visual programming languages allow you to do things in a more visual environment. Last thing I'll show you is like VS Code. So VS Code is an IDE, and Visual Studio Code allows you to write software. This is the software for creating software. And so you keep all your files and you open them up and you could see them and you could run stuff down here and you could see the output. And so VS Code is the IDE, Integrated Development Environment, which is best to use. It's the best one right now, mostly. Like, you might find some reasons to do something else. But if you're just starting out, just use VS Code. That's it. That's a lot about programming. I hope you enjoyed it. I enjoyed it. It was fun. I enjoyed talking about it. And, it's a really interesting field to go into. It moves really fast. And you need to be willing, you got to really be intellectually geared towards sitting there and solving engineering problems with precision. to enjoy coding. Otherwise, if you get into coding, you'll probably find yourself moving up into management after working as a coder for 10 years. If you like working with people more and talk, like coders like to work with people. A lot of coders are really great people. They're great people. But there's a lot of time where you're just sitting here solving problems. And you need to be intellectually geared towards it. You got to be pretty like you've enjoyed engineering and you've enjoyed math and you enjoy solving problems, because there's a lot of time just sitting at your desk doing that kind of thing. But it's also like, if you're good with languages, it's very much a language. And so like if you enjoy, like once you learn to speak it, then you're just doing that all day, but you're doing it with a computer. So I really like talking with humans. Ironically, even though just a little personal information, I grew up and I survived a traumatic event, and it left me with PTSD and a really big fear of humans, a really huge fear of humans. And if I could have just avoided humans for the rest of my life, I probably would have. But there's part of me that loves humans so much, and I love interacting with humans. And so being a teacher who teaches about programming and teaches about computers, that's fit me well, because I like communicating with people and interacting with people. But sitting at my desk all day for 6 hours a day writing code, that'd be too much for me. And so that's kind of what you got to ask yourself, if this is a career I want to go into. Like, am I really social, love interacting with people, or do I just want to be in the office by myself for 6 hours a day, solving problems, engineering stuff, and writing that code? You got to ask yourself that question. And there's a lot of collaboration, of course, in computer science and talking with humans, but there's also a lot of sitting at your desk writing that code. I mean, like, there's me sitting at my desk here recording these lectures, and but that's somehow different. Somehow that's geared more towards who I am and the environment I was raised in. My dad was a teacher, and my mom was a teacher for a bit. So you just have to think about those things, right? Because I know somebody who is going from being a nurse to being a programmer, and I know somebody who's going from being a programmer to being a nurse. So you got to make sure you make your choice for what's going to fit you well. Otherwise, you're going to have to retool somewhere when you realize it wasn't the right one for you. Hey, have a great day. Whatever you do, hope you have a good time and enjoy other people, and be kind to others and be kind to yourself. And know that you've done a really good job. If you've watched this lecture to this point, when you go to bed tonight, as you're laying in bed and you've said your prayers of love for everybody that you love, including yourself, just a suggestion, it's what I do every night. Also take a moment just to appreciate yourself and to be like, I did a good job today, and here are the things that I did which were good. And you watch this lecture, you moved the ball forward, you learned something new, you advanced your knowledge, you're advancing your skill set. You're moving forward in life so you can contribute to the team, which is humanity, at a higher and more effective level. And you can understand this world that we've been born into more effectively. I mean, think about that dark matter, right? Wow. We don't know anything about it. And what was the other one that was really interesting? So dark matter was really interesting. These books were really interesting. And and that we don't really understand how AI works. That's really interesting. And that the more you learn, what you learn is how little humans have learned. So all super interesting. You did a great job pushing the ball forward. I got to jump on a call actually right now. I'll see you next time.